Lesson 3: Hardware Upgrades, OS Installation, and Troubleshooting. In our final lesson, we will cover hardware upgrades, operating system installations, and troubleshooting. A common reason to upgrade a PC's RAM is to allow more applications to run smoothly when software requirements increase. However, you cannot mix DDR4 and DDR5 memory modules freely on the same motherboard. They use different technologies, slots, and electrical standards. When selecting a new CPU, the most critical factor is ensuring the motherboard socket type and chipset support that specific CPU generation. Organizations must plan for upgrades because they can cause software compatibility issues and require user retraining. Before installing an operating system, you must confirm the PC has enough RAM, CPU capability, and free storage. During installation, creating 2 allocated partitions is useful because it separates the operating system from user data, aiding in organization and recovery options. To configure a system at a basic hardware level, a technician accesses the BIOS or UEFI by powering on and pressing a designated function key during early boot. Here, you can view hardware health status and configure the boot order. If you install a new part but the system reports a failure through post-beep codes or on-screen messages, you likely have a hardware problem with the memory, CPU, or motherboard. If a newly installed RAM module is not detected, your first step should be to reseat the module and check it is fully locked into a supported slot. Sometimes a component is dead on arrival, meaning it fails immediately and must be replaced. Once a hardware upgrade is working, such as a new network card, you should install the correct device driver, verify it in Device Manager, and complete your documentation by recording the reason, proposed solution, implementation, testing, signatories, and date.